Okay, next we look at modulus argument. Okay, for modulus argument, okay, it's like this. You based on the Argand diagram. Okay, based on the complex number. Okay, you find the modulus. Modulus actually is the R. This the R. Okay, R is modulus Z. So how to find? Use square root x squared plus y squared, just like Pythagoras theorem. You want to find the R, you find x squared plus y squared, then square root. Alright, just like Pythagoras theorem, you have this y and x, then find the R, relative line. Okay, so actually this is like a circle. This one can move a circle. Okay, so this is R. Then the theta is here. This is a theta. Theta, how to find theta? Actually, okay, you can base on the value of y and value of z. So this y and z actually is the one of value x is the real number and then y is the imaginary number. So you can get from the complex number, this one can get from z equals to x plus yi. Okay, so just find the arctangent for y over x. Okay, you can get the value of theta. And then in this modulus argument, the theta must be between negative pi and pi. So they must be from here, calculate from here to bottom here, negative pi. And then this one from here to here, pi. Maximum pi, minimum is negative pi. Cannot more than pi the answer. Okay, for argument. Okay, understand. If you get more than that, more than 180 degree or more than pi, you must check the negative angle. You have to count from here to here. Okay, cannot count more than pi. Okay, if the angle comes to third quadrant or fourth quadrant, you must change it to negative angle. Okay, based on the position, you change to negative angle or positive angle. Okay, make sure remember the theta must be between this only. Okay, in the complex number, okay, make sure the theta, you know your idea is theta, but you must write argument z. You don't write theta anymore. Okay, when you state the angle, you state argument. Argument of the complex number arctangent y over x. Okay, if z conjugate is a complex conjugate. Okay, don't care because complex conjugate you'll get the same thing. Because complex conjugate is the y equals to negative, correct or not? The y will be negative, but you square, you'll get the same answer, correct or not? So you get, if z times complex conjugate, you get x squared plus y squared, because z modulus is square root of x squared plus y squared. The z conjugate also square root of x squared plus y squared. So zz is x squared plus y squared. Same like that, the concept is like that. So zz conjugate is modulus z squared. Okay. Okay, you see this, you can find that is actually is the step. Okay, you find the modulus for z conjugate, you get the same answer. Okay. Okay, we look at example 6. Find the modulus argument of the complex number. Okay, this 4 represent 4 complex number in 4 quadrant, 4 different quadrant. Okay, we look at first quadrant. Okay, normally first quadrant not many problem. If both also positive, the number is at the first quadrant, right? So first quadrant, you just find as usual, find the modulus, all positive, no problem, find 2. Then argument is the angle here, right? Angle here, so because positive, you just press calculator. Okay, if you press calculator, you get degree, but you must change it to radian. Okay, for argument, every time you must change to radian, don't give degree. Okay, how to change to radian? Okay, if the angle is 40 degree, 30 degree, 60 degree, all these are common angle. common angle, try to change to pi form because you can change to fraction. Okay, so you press calculator here for arctangent 3, you will get degree, right? So just divide by 180, then put a pi at the side, then give the answer in fraction. Okay, understand that? If the degree you get is a whole number, no decimal place, you straight away write like this, write pi form. Okay, if you get decimal place, you can divide by 180 times pi. Pi, just press the calculator pi. Okay, don't press 3.142, press the pi, understand not? The calculator got pi, right? Press the pi, pi is how many? 3.142, right? Yeah, don't press that, you press pi. Okay? Okay, to get answer in radian, okay, without the pi. So you have to times the pi. If you give the answer in pi form, then you just divide by 180 only, right, in decimal place with the pi. Okay? So this is first quadrant. For this second quadrant Z2, if the complex number in the second quadrant, so every time if they ask you to change to find the modulus and argument every time, first thing you need to find out is where is the position of this complex number. First thing, okay, you must know, is it in the first quadrant or second quadrant or third quadrant or fourth quadrant? Okay, first thing, you roughly know. If they didn't ask you to sketch the argon diagram, no need to sketch exactly, never mind. But here they ask you to sketch, then you sketch properly. Okay, if they didn't ask you to sketch, actually just simply put on it. Okay, you must know where is the position of the complex number, because you need to decide whether you need to take the basic angle or complex or acute angle or obtuse angle. Okay, so the second one, because of -1 is in the second quadrant. Normally, even in the second quadrant, you must check the basic angle or the reference angle. Some you said this is reference angle in the first quadrant, right? Find out this. Very important. You find out the reference angle or the basic angle. First, you must find out. And then, this is the angle that you get in the first quadrant. Okay, because this is in the second quadrant, you use pi minus this. Okay, because this is right in pi form, so you just take 1 minus 1/3, you get 2/3 pi. Can you see that? Pi is 1 pi, right? Okay, here is 1 pi. Minus 1/3, you get 2/3 pi. Okay? Okay, this is how you get this. So pi minus pi/3, you get 2/3 pi. Because second quadrant. Okay, then next is, if in the third quadrant, okay, you don't go and calculate this and then plus the pi now. Because if you plus pi means more than pi already. That's not the correct answer. So you must change to negative angle, negative pi. So if at the bottom here, you must use negative pi minus the negative pi over, because minus pi/3. Because you have to change to negative pi already. Okay, so here is pi/3. The bottom is negative pi/3. Okay, because at the bottom. Any problem with this or not? 2 pi/3. Actually, this one like this. Okay, if at the top 2 pi/3, at the bottom negative 2 pi/3. Then the other one is negative angle. Because in the fourth quadrant, so you have to use negative angle. So here is for every time here is positive angle, the reference angle. But because this is fourth quadrant, you have to change to negative angle. So positive, you just put the negative. Okay, so this one should be negative pi minus this one should be like this, should be negative pi minus pi over 3, okay. Hey, any question for this or not? Because of negative angle, okay, because of third quadrant, so you get negative 2 pi over 3. Pi minus pi over 3. Actual one is here, right? This is first quadrant, right? The pi over 3 is at the first quadrant. Alpha should be pi over 3. Basic angle. Huh? Always find the basic first. And then you check the quadrant if there is inside here. So you, as usual, because here is a respect of the top to the bottom. Okay, you just assume that pi minus pi over 3, put a negative in front only. Okay. Okay, understand? So don't go and use the pi plus pi over 3, no, then you will get wrong answer. Okay. Next is for this, sketch Argand diagram and find the modulus argument. Okay, any problem or not? Sketch the diagram, then find this modulus argument only. Make sure you state argument. Don't state theta. If they state argument, don't go and put theta. Okay? Make sure argument, put argument. Write like this, argument, RG. Okay, you know this is theta, but you don't put theta there. Okay, you put theta, no marks. Okay? Later got a lot of people put theta later. I don't know. I thought nobody want to listen. Okay, then next. This one you can do yourself, very easy. You just follow, draw the diagram and then do. Okay, next. Complex in polar form. Okay, this is the next step. After you get the modulus and argument, you just substitute into the polar form. Just substitute into this form. This is the polar form that involves cos theta, sin theta. So the modulus you substitute to R, the argument you substitute to theta, then finish. You can get the answer already. Okay, this is complex number you write in polar form. Okay, this form is very useful. Later, if you want to find the raised to a power, okay, or you want to find the roots of complex number, very easy if you change to polar form later. Okay, so now you just need to, what you need to do is change the form of complex number to polar form. Cartesian form, this is Cartesian form. This z equal to 3 minus 4i, w5 plus 12i. This is called Cartesian, means in the graph, in a 2D graph, Cartesian form. Okay, this polar form is a circle form. Circle, then with the theta angle. Okay, so you already find the R is the radius, then the theta is the angle. You find the argument already, right? Argument you put in the theta, and then the modulus you put at the R. Okay, so how? Okay, this for example 7, they didn't ask you to find draw Argand diagram, but you need to know where is it. Roughly you need to know. Okay, first step, every time they ask you to express in polar form, first thing, okay, remember, first thing you need to do is, where is the point? You must know roughly the point. Where is the point in the Argand diagram? You just put a cross there, then put first or second or third or fourth. Okay, so that you can decide whether you want to put positive or negative. Okay, first step you must know where is the complex number in the diagram. First, okay, after you state in here, okay, here is 3 minus 4, so here. Okay, so if here you try to check every time, find the reference angle or basic angle. Okay, you show what is the answer. Okay, normally you press calculator, If you calculate in degree, you get this, or you can change to radian actually. You change to radian, you straight away get this. But you cannot get the pi form lah, you straight away get decimal place. But sometimes if the degree is 30 degree, 60 degree, it's better you change to degree so that you know you can change to fraction form like this. If not, if you straight away change to radian, you won't get the pi in the pi form fraction form. Yeah, you will straight away get the decimal place on it. You change to radian. You change you know what I said or not? Calculator, you got one function, you can change to radian straight away, correct? Got it? Now to do or not? Don't know got degree, got radian, you straight away press, you get this. Okay, never mind. It's better you change to degree, then you just divide by 180, then if there is decimal place, you straight away times the pi, you get this. Okay? Okay, then next, this one, so this one is how you get this. Okay, then how to get this? Because of negative, because this negative is just at the bottom of the positive, so you just put a negative in front, because bottom, this is positive angle, this is negative angle, so from positive you change to negative only. Okay, no need to minus or plus anything. Don't use 2 pi to minus this, then you get wrong answer. Okay, first quadrant is negative angle. So you just substitute here. Substitute this only, negative, correct already, fully get full marks. No need to change to negative. Okay, some they like to change. Oh, I know cos negative become cos positive. Negative, I put the negative in front. Correct. But if they got further question, sometimes you need to use this. Some students forget to put back the negative. Then you'll get wrong answer for the second part. Okay, both also correct. You can put negative in front. But if you got further question, make sure you put back the negative inside here. Because this is negative angle. Okay, later we look at the further one. We need to have combination of cos angle plus I sine angle. Okay, and then this one should be same. If you see a negative in front of I sine, if you want to do that type of question, you must the negative you must change it to inside become the angle, negative angle. Then the cos angle must be negative. Both angle must be same. If sine angle is negative, cos angle must be negative. Sure. Okay, okay, even they put positive here positive, but because of before I sine is negative, you want to change it to positive, you must put back the I inside the angle, right? Become I sine negative angle. Okay, if I sine negative angle, this must be negative. And then you must remember the cos negative angle is equal to negative cos angle because of what? For cos positive, first quadrant and the last quadrant also positive. But you remember this. Cos here also positive, cos here also positive. That's why. Okay, here negative, here negative. Okay, this is B, then B. You look at B, this is first quadrant, no problem. After you get this, you just substitute inside the angle. And this is the modulus. Okay, so this is modulus, this is angle. No need to change actually. Okay, the third one. You have to draw the graph. Yes, you roughly, because they didn't ask you to draw, you just help you to find out which quadrant is the complex number at. Okay, so you must know. If not, maybe you will give the wrong angle. Okay, so this one, you see negative 2 is here. So you know here is positive, but the angle should be more than 90, more than pi over 2. So if here, the basic angle is here. Okay, what you get is here, but because of here, you use pi minus this, you get this. Okay, you press the pi in the calculator, minus this, pi is roughly 3.142. 3.142 minus this, you get 2 point something, okay lah, correct. Okay, that's why the answer cannot be more than 3.142. Maximum is 3.142 or negative 3.142. Okay, if without pi, you pi different line generator lah. Okay, this one without a pi. Okay, when some maybe we'll ask question, you didn't ask question pun. Other pun. Okay, when we know we need to change all to decimal place or no need to write the pi. Normally, if this is decimal place, you change to radian, right? If you want to change to radian, sure it's decimal place, correct or not? If the angle is decimal place. If angle is decimal place degree, you change to radian, you divide by 180, you get decimal place, correct? So normally you straight away times the pi, so that you get the whole thing decimal place. So this is in radian decimal place. Okay, for the first quadrant. Then if you want to find second quadrant, you just press the pi in the calculator minus this, you'll get this. Then you no need to put the pi at the side there because everything is decimal place. Okay, when do you need to put the pi at the side? Like this, this type of question. This type of question, if you get like 30 degree, 40 degree, the whole number, so you can automatically divide by 180, then you get a fraction form, then you put the pi at the side, no need to times, because you no need to put in decimal place. The answer will be more accurate. Yeah? Understand? Okay, for question not when to put the pi, when no need to put the pi. But sometimes the question asks you must write in pi form, then you have to put in pi form. If the question didn't mention, actually both also they accept. But you can decide normally if a lot of decimal place, you just times the pi, then give the answer in decimal place. Okay, if there is a whole number, you just divide 180 and then put the pi at the side there. Okay. So this is how you do it. Okay, you find this, then you find this. Because this is in the second quadrant, pi minus, you get this, then substitute the angle. Okay? Okay, then you do this. 3, 4, and 6, 8. Okay, 6 and 8. Settle. Finish,